All right, some underground ops happening with the Underground Nexus. Some more Underground Nexus going on today. So, my name is Nato Riley. For those of you who've been following for a while, you're familiar with me. And Jermaine, go ahead, and this week we'll have a better introduction for Jermaine. Jermaine, introduce yourself and just kind of let everyone know who you are now that we're doing things. Oh, now that I think the audio's not working in. Hold on. What did I do wrong for there to be no audio? Well, we're gonna test the audio. So say something,
Okay, yeah,
Jermaine,
I think
again.
so. It's working. Sorry, there's a little delay. So.
Mic check.
Oh, now
Is
I
this
hear
good?
you. Now I hear you.
Okay.
There
All
we
right.
go. Now you're solid. Okay, now continue. We're good.
Okay. All right. So yeah, my name is Jermaine. Nate already said that. I guess you could say I'm like a student of cybersecurity, DevOps, DevSecOps. Learning every day. I'm kind of obsessed right now, enjoying every minute of it. I'm excited to be on the underground ops stream right now.
Thanks for joining us again. So some things that I'll kind of touch on. We've been working on this tool called the Underground Nexus. Jermaine is part of the DevSecOps dojo, and we've been spending a lot of time pretty much just building tools for DevSecOps, learning things about DevSecOps, and of all the things, when it comes to security and all that stuff, I guess Jermaine, my question to you is, what are some of the things that brought you into wanting to work with security and things like DevSecOps and wanting to do the actual real work like this versus just, you could be doing anything else, but you chose to do the real work.
I guess for me, I've always been a hands-on person. There's no doubt about it. Like this is what I enjoy. So for me, it was the obvious choice. I also have always been involved in like a company where there is development going on, but I'm just the IT support guy, and I don't really get to see what's happening. And then when the time comes to actually support the product, since you were never a part of the development and you're just like the desktop guy or you're even just like the network guy, you're like, wait, why is this error happening? What happened? And why doesn't it work on this piece of hardware and it works on that piece of hardware? It's like now I really want to be a part of it from the beginning. I want to understand it. I want to understand production flow. I want to understand, especially like the security aspect, because now we're seeing it even more where I feel like we're moving towards that direction where everything is code, like our infrastructure is code. Uh,
Yeah.
every single everything that's like on a phone is a piece of code, right? And we need to really understand the security part of it. So for me, it's just the obvious choice, you know.
It makes sense, and everything is becoming code these days because it's like so what I just added to the background there for everyone watching, and I don't know what's going on with the camera. I'll see if I can make the camera not do what it's doing. But everything these days is becoming code, just as Jermaine says. And once upon a time, so I come from working in data centers. That's something that I spent a lot of time doing, like in the rooms with the racks of servers where you have like the floors have vents and you have like one side of the server racks that blows cool air up, and then the servers would suck in the cool air and then it would exhaust the hot air into the back that gets sucked into the back floor. Like, I mean, that's the world that I come from. And in our modern world, like, I can do the same things by just downloading something like Docker Desktop, which if I just go over to Google, I can say Docker Desktop, and I can just select this. And, if I'm just using Linux or Mac or Windows, I can literally just download this tool, and then the you know, the craziest thing is suddenly I can actually just come over here, and this is a website where you can come over here, go to the Underground Nexus, and it's copy paste data center. So you can just say, I want to copy this data center, and then you just go over to your terminal after you install Docker, and this is a test, so that this environment's not real, because well, it's real, but I'm using it for showing what's going on with things, experiments, all that good stuff. But still, I can come in here and just paste a data center, and then I can run that data center and say, I want this data center. It's going to sit there and start building it. So this is how you get started with the Underground Nexus. But you used to have to go and sit there and do wires, and I'd be sitting there all night, you know, crawling under desks and stuff, making sure I'm getting the wiring going to get people's desks wired to all of the stuff, you know, running wires. Used to have to do so much wire running. We actually still do wire running, but, you know, I don't have to do it every single time I want to get someone connected to an ecosystem anymore. I can toss it up into a Git environment, which is just like this, just paste it, and now all I have to do to use this copy paste data center is just copy this next part right here. So where it says activate, I now just have to activate my copy paste data center by copy pasting the next thing. I'm just going to copy this, just going to paste this in here, and there you go. Oh, it says that it's not running, so I can, let's see. Either way, you just run those two commands and it generally just works. I probably have to do something, but this is actually running inside of one of these things itself, so I don't necessarily know how well this thing runs inside of itself, but everything you're seeing here, this is how that works. Really, you would want to use, like, if you're using Windows, there's Windows command line. You can type command prompt right here, and you would actually really be pasting it into your Windows terminal shell after getting Docker Desktop. Some Sports Illustrated for you. But yeah. So that is more or less how you one of the ways to get a data center these days. Now, Jermaine, you used to build systems, probably still do. Do you still build your own computers for things, or build systems for things?
Yeah, I'm actually getting the hardware right now to build like my gaming rig. So yeah, I still do. Like, I love it.
There's something nice to it. And then still, like, if you have a good system to run this on, it runs even better. So while you can actually run the Underground Nexus on anything from like a Raspberry Pi all the way up to like a big beefy system, I'm using a big beefy system right now, but whether it's Linux or whether it's Windows or OS 10, you can pretty much get all the benefits of having like what's kind of like AWS, but you can have AWS live wherever you need it to live without going and paying the cloud bill. So like if you, yeah, it's like a downloadable AWS, maybe that's the way to put it. But anyways, so once you have the Underground Nexus up and running, just a high-level tour of some of the things that you'll notice is if you go to the URLs inside of the Underground Nexus website, so if you look in the links for the stream in the description, you'll see the link to the Underground Nexus. Today we're going to talk about how to start using some of the resources in here. The main one is if you go and take a look at Portainer right here, these links on item 9 work while you're inside of one of the Underground Nexus web tops. So you'll notice you'll have to type in the IP address, whatever the IP address is of the system that you're running the Underground Nexus on. And there's some guidance up there. If you're running it on, like, say, your system that you're using, like if you're using a laptop and you're testing it on that laptop, then you can just use this guidance right here that says use localhost. And then if we take a look at these links down here and we go to Portainer from inside of the Underground Nexus's desktop, which is maybe a little confusing looking. It's a little confusing. So this is actually a Windows 11 system, just so that we're all very clear here. And so the Linux that you're seeing on the screen is running inside of a web browser. There's a whole computer inside of a web browser. There's actually multiples, as a matter of fact, that we're going to take a look at. This one's running on a Raspberry Pi, so there's a little data center running on a Raspberry Pi here. There is one running on just another system, so this one's one's a Windows, so this is a Windows system running the Underground Nexus. This is an Apple system running the Underground Nexus, and this is a Raspberry Pi running the Underground Nexus. And also notice that I can access all of these systems remotely from one location, just from a browser. And every single one of them is its own workspace, so who uses something like this? Like if you are a person who works with data centers, or like you're a managed service provider, or you're like a developer building apps, especially if you use tools like GitHub and stuff like that. So, you know, that's who would use this sort of thing. So if you use tools like Visual Studio Code, and that's something that you use, or GitHub, it has tools like GitHub Desktop. That's really what this is made for, is like Git tooling. And then we've got over here all kinds of stuff. We've got Visual Studio Code, and it can run virtual machines inside of it, which I will actually show you. It can run any virtual machine. It can run Windows inside of a virtual machine inside of one of these things. I did have actually I think I do still have a Windows virtual machine running, but I'm not going to go over Windows virtual machines today in particular. If anyone wants to see Windows, there's Windows. We're not going to spend time on Windows virtual machines at this time, because they spin up the exact same way. You can set up a Windows virtual machine the same way as a Linux virtual machine. So Portainer, these little tabs right here, Portainer is sort of like the manager for the Nexus, so that you can come in here and take a look at all of the resources and tools running in here. Notice I had built the Underground Nexus inside of itself. It probably has some port conflicts and some other things that are causing it to not want to run in here. And the other thing is I have this Pi-hole, which is the next thing that I was going to show you, where it says Pi-hole. If we look at these links here, it opens up all the different service URLs. So the next one being Pi-hole. The Pi-hole actually blocks things from running inside of the Nexus that might be malicious or shouldn't be running in there. And it'll also block links and URLs. So one that is pretty common if you want to go try websites that tend to be ad heavy, you could go over to, say, like IGN.com, and you will notice that it blocks quite a bit. And that's thanks to the Pi-hole over here, which also it does block malware. You can't likely block 100% of malware in this world, but anything that you have that can help block malware, the better. Now, see, this is IGN.com running in the Underground Nexus. Why does it block so much? Because the Underground Nexus is designed for people who are developing sensitive code that should be protected, that really, the last thing you want to get hacked is where your code lives. And it actually keeps your code safer from the system you're accessing the Underground Nexus from. So while I might not come in here and access all of my sensitive accounts on this Windows machine, that's then what the Nexus is for, because then I could even, on my own machine, and like if I was a manager and I was like trying to tell my employees not to get the company hacked or something like that, and I'm like, don't click on ads, you can't control what people click on. So if someone is a developer and they're like coming in here and they see like the, well, here, that's their browser, that's their system. It's not a big deal if their system gets hacked because they didn't pay attention to what they're clicking on. At least they're not taking out their whole company, because then that also takes their job from them as well. And we don't want that. We don't want to get hacked, things like that, especially if you're an app developer. So the Underground Nexus, then it has its own environment where it blocks things that might threaten you or your company or your company's code, especially if you run your livelihood with code. If you don't run your livelihood with code, this might be overkill security. But it's for people whose lives live in code, and you don't want to lose everything in your life. If you work with like AWS, Azure, all those things, I mean, you probably have backups and stuff. So continuing on with items that you'll run into in the Underground Nexus is if I select this torpedo, oh, does it say HTTPS? What is it telling me? http:// Well, I might have to double check some of these links. This is probably worth. So we did just build this tool, and I'm just lining things up by the day. I didn't realize this was HTTPS. Not that that's actually a good thing, or maybe it's not. Oh, you know what? I did something to this system. It's actually running in some special thing that's blocking it from being able to access. This is the window that should be showing up, and that link is only broken on my system. If you're using any other system, it should work properly. I am running like an experiment, which I will show you because I'm making all of these systems work together. But anyways, this is what would pop up there. And the login and username, the default login and username is right here where it says MinioAdmin. That's going to allow you to log in. And this, you can open these ports. You can turn any system into a NAS with this right here. And you can make this an accessible website outside of the Nexus if you wanted to configure it to be so. So let's see. One thing that I will show you in relation to that not working is you can make these little systems talk to each other, which the thing that is really interesting. Right now I disconnected all of these, but you can cluster all of these together, and notice that all of these are available for me to synchronize and send services to. And so you can actually distribute services and create like a collaborative environment. So like if I was like a manager and I had a bunch of people who I wanted to like deliver services to who are running these little things in the background on their systems, you can link different nexuses together. That's a thing. So you can cluster them. So before I get too far into all of this kind of, I guess the last things that I want to touch on before we kind of get into questions from Jermaine and then getting into like virtual machines, because we want to talk about how do you set up a virtual machine. The other things to pay attention to is there is another desktop that is designed for building a security operations center in. Let's go look in Portainer and see what it's doing. Okay, so if I go, oh, I see the little agent because I was messing with it. So this thing is taking over that port that wasn't working. Let's see, 2000. Okay, so let me connect to this other desktop. There's a desktop inside the desktop. I think I can actually just come up to the top here. Actually, no, I can't access it from outside of it. Hold on, I'm probably being very confusing. At some point I'll find a much better way to like show all this stuff. Well, I will have to figure out why it doesn't just route to that IP address. So there's some things that I'm working on, but you should be able to, if you access that IP address here on a non-tampered with system, because I have tampered with this system heavily. If you go to this URL here, it should show up, which, like I said, I'll take a look at. But anyways, that is an overall tour of the default items that live inside the Underground Nexus. Then you have GitHub, because it's a Git tool really, and then it has Git Kraken, which is a Git shell, which I have already set up on one of these systems. So Git Kraken is basically a fancy shell for working with Git. Which I will probably have to mess with another time, because this system I have a lot going on with it, which I will show, but I'm running a bunch of virtual machines and things like that. So before I get into virtual machines, things like that, because it shows down here deploying virtual machines, based on what you're seeing, Jermaine, what are some of your thoughts what are some of your thoughts having worked with the Underground Nexus and kind of getting started with it and figuring out like where do I begin with something like this, like learning Git? What are your thoughts on Git?
Like for me, I guess I do find it very interesting thinking about developing within that environment because I did start outside of it, right? And now starting to do everything in there, it's like, okay, actually, I see the point. Because even the what you just said about like browsing the web and thinking back to working at some companies, when they implement web filtering and they try their best to stop employees from going to websites because they don't want these problems. But because you implement the web filtering, then people find a way around the web filtering and you get even more problems.
Yeah, that's very true.
So this is like it's very interesting to actually hear you speak about it because then it opens my eyes to different ways of looking at it. But I guess the like messing with Git has been an experience because building out your repo, making sure that you're actually what do you call it whenever you initialize it.
Yeah, all the
And
initializations.
yeah, like that whole process is a lot.
It is.
It's a lot, and it's good that you actually have this environment to do it in because you get to stay organized on this because that's exactly what it is for. It's just for development. This isn't like your personal desktop. This gives you access to exactly what you need it for, which is coding. So for me, it's been keeping me a lot more organized.
That makes sense. So, for your first experience working with, so this is GitLab right here. It's just one of many Git tools because we were talking about the fact that you can work with GitLab, you can work with GitHub, and then there's also GitHub Desktop. So this is built to very much so just kind of work right away with like your Git tools. So you can have GitHub Desktop right here working in direct conjunction where maybe you have Visual Studio Code that might hook into GitHub resources. And, regardless of what you're building, you could have it set up to where you can just come in here and scale into the cloud. So this thing that says like connect to code space or create new code space. This is the actual pipeline or a pipeline that's heavily secured that allows me to work here. And even if people are watching what I'm doing here, you can't just get into my environment. And it makes it even safe enough for me to just show you this, knowing that you can't just get into my environment. And it makes it easy for me to teach. It makes it easier for me to not worry about breaches at the same time because my whole pipeline is just chained all the way from here's GitHub, which is part of the Nexus development pipeline. And then we have this thing that just has a permanent IDE just hooked into the pipeline that then hooks into GitHub, where I don't even have to think about any of these things. It does it all on its own. And then this system doesn't even have access to the core pipeline that has the power to modify the Underground Nexus. So I can't even get in there through this particular account. There's some sneaky way for me to even come in here and update it. And then whenever I update what I'm doing from this thing, without me even thinking about it, it automatically updates it here, which I don't even have, I never have to touch this. It just automatically does this. It automates it. And then it goes all the way, if we go over to hub.docker.com. So if we go all the way over to hub.docker.com and then type and we come over here to the Underground Nexus, this is yet another thing in the pipeline that it automates that I never even have to think about. I don't even have to now I monitor it from a security standpoint, and it automatically vulnerability scans the whole Nexus for me. So I have vulnerability scanning automated. I have image generation automated. I have everything in GitHub pretty much automated. And then all I do is go into a specific GitLab host, and then I have multiple GitLab hosts and an entire research farm. And Jermaine, you're in the research farm. You know that side of the pipeline. But I can share it with everyone, and it's not the end of the world knowing that Jermaine has access to this. Do you feel like it's easy to hack the Nexus code from here if you try to mess with this, Jermaine? And do you realize that no one can just access this? That's pretty neat.
There's no, at least not from. I don't see a way in. Like, that's for sure.
It's definitely complicated because even if just to give you an idea of the benefits of having like a fully automated pipeline, because these things automate pipelines, if someone were to breach this account right here, this regenerates like a starfish. I'm sure like there are probably ways for it to have a complete takeover, and I don't want to invite that sort of a thing. But still, if I have some disastrous catastrophe, or let's say I accidentally came in here and deleted all the wrong things or something like that, it's so low risk that, let's say that, because this connects to something called code spaces. Let's say I connect to my code space thing, or my code space gets hacked to this, and then someone comes in here and just messes with the Underground Nexus and tries to hack our entire audience. It heals itself. It's a self-healing repository on top of all of these crazy things, and it's all done centrally through a series of the tool that we use ourselves, which is the Underground Nexus. And then the strangest thing is something that we're going to talk about a little later. Well, actually, maybe we can talk about this now. Well, I don't know, this is a different session because we're going to talk about virtual machines today. Maybe we'll talk about this Thursday. So, Jermaine, don't let me forget, this domain is a hidden domain that we did buy that lives exclusively inside the Nexus, that you can only access inside of a Nexus structure. And if you don't have a Nexus structure, you can't actually access this website. And this is the way that we hide our primary Git. And so there's, I don't know, it's so scary to figure out how to even get access to this one resource right here. And then you can, like, block people out of this domain with ease because it's, I don't know, it's really strange. Any questions about all that automation stuff, Jermaine? Because you've been working with like GitLab runners, and you know how terrifying this stuff is. What?
Oh yeah. No questions right now. But, you are right about GitLab runners being definitely scary.
How would you describe a GitLab runner to people who don't know what a GitLab runner is?
All right, so you know, like, think of a pulley system. Right, you put a bucket of water on this pulley system, and it has its destination. You're just hoping that it makes it, but you know what? Like, along the way, there might be some bumps, and some water might spill out, and that's what the runner does a good job of. The runner is actually like, oh, there's a problem here. We're gonna send that water back. We're gonna refill it, and we're going to make sure that it makes it to its destination with no problem. That's my best way of looking at it.
That's pretty good. That's kind of like, it's because I can't figure out how else to explain it. That's like the best I think of too, because it's like, yeah, it just like runs out there and it's like, let me refill this. Okay, when we come back, we got to get like more of the resources here. Here's those resources, and then you can choose where you want to send things, so you can have. You can tell it where you want its destination to be. And you're like, all right, we need to make sure that over there has resources, that over there now needs some resources, and these things all over here need their resources. That's a good way to put it. So when you have tools like Git and Git tools, and you're doing things like what we do, where you have continuous technologies that are pretty much all code build based, and we do almost everything with code build, including the idea of copy paste data centers, right? So if a copy-paste data center is to even work, what if you were to like set up your own little copy-paste data center, set up however many nexuses, just like this? You see there's multiples of them, right? You can have as many as you want. And then just as I was showing you, you can even make them talk to each other, right? You can be like, okay, all of you nexuses, we're going to all have conversations together. We're going to work together. We're going to have a good time. you have all these different things. Well, all of a sudden, let's say that you wanted to just make them all kind of work together as like one environment, just like one supercomputer sort of a thing, or like a hybrid cloud. Well, you could, from your Nexus, then have some of the runners host some of your code in Azure and AWS or something, or Google Cloud Platform. Doesn't matter, wherever you want. Just wherever you can set a runner, which is like anywhere. Or then you have some jobs on a Raspberry Pi, or maybe there's a whole bunch of Raspberry Pis. Maybe you have, now I don't know how many people have just like a whole bunch of random homes, but like let's say that you have a family member, like let's say that you're going to college and your parents have really good internet, but all you got is a laptop and terrible internet. You'd be like, hey parents, I'm trying to start this company or trying to do work with the continuous pipeline. I want to install some Raspberry Pis back at home and a little VPN, and then make the home base my data center, and then you can then wherever you go have like your traveling data center, but then you have the home back at home just always running, right? Because I mean, you know, folks got family members, so if you don't have family members, you can always find your found family too. That's the thing. Find your found family, or just like one day when you just get really good with Git and you start getting these fancy jobs, just buy like 20 houses, and then all of those no I don't know if you need like 20 houses. You get into like Airbnb and put like 10 Raspberry Pis in every single Airbnb, and then it's an Airbnb and a data center at the same time. Business model. Who's got it, right? Anyways, I don't know. Someone's got a whole bunch of Airbnbs and a bunch of Raspberry Pis and is ready to create like a global data center out of their Airbnbs. But the Nexus allows you to do that, and then you can also scale your Airbnb data centers where people are already renting them out. You know, you're using those internet pipelines to make money on top of that. Plus, you could get some AWS nodes and some Azure nodes and some Google Cloud. Why limit yourself? You could just have everything. Just have all of it, right? So anyways, I don't know. The Nexus is like the overkill solution if I want everything to be everywhere. But it does it with code build. And with runners are the way that you essentially handle that management where, you know, let's say that you do have a bunch of sites with 10 Raspberry Pis and AWS. Put a runner in all of them. Runner on every Pi, runner everyone AWS, boom. Now you can control everything. And because the Nexus is code build based, then you can just follow the same kind of formats, and doing everything with Git then just lets you kind of control everything everywhere. You can have a data center without a data center, because I come from building data centers. So for me, why did I build this? Because I was like, I want all the benefits of the data center, but without the data center. So I guess any questions before I kind of show you how virtual machines, Jermaine, because we can spin up virtual machines inside any Nexus on any device, and we're going to take a look.
No questions right now.
Okay. So we're going to take a look at virtual machines. This does have, if we take a look at the menu, if we go to all, or we go to the bottom, and we see have this virtual machine manager. If we go to system tools, that's really probably the easier way to find it, is just to go to system tools. You can find the virtual machine manager, because all has too many things. Maybe not too many, but anyways, the virtual machine manager, if it doesn't automatically install itself on the Raspberry Pi, that's the one time that you might have to come in here and set up a shell. Like there's this thing that says Nexus bucket. The Nexus bucket has this item called Workbench. So like if I go to a cleaner environment that's not all crazy, here we go. So this is a Raspberry Pi. If you're running it on a Raspberry Pi, you might have to come in here to get the virtual machine manager, and if for whatever reason you don't see the virtual machine manager down there, then the way to get it would be to go down to the menu, go find your terminal shell. So it's this mate terminal right here, and in your mate terminal you can navigate to this path, which you can actually just copy paste. So you want to copy this path here. I'm going through it kind of fast. So someone might have to hit the pause button if you're really trying to do this. So you might have to then say CD, and then you paste that there. If you type ls, just like this, then you'll see that that script is there. And then you can type sudo sh, and then you type the name of the file. Now I'm not gonna run that because I don't want to reinstall anything, because I actually have a virtual machine manager running and I don't want to accidentally stop it somehow or cause it to not continue running, so I'm going to exit that. But that is how you can get your Raspberry Pi ready to start being configured for virtual machines, and then there are a few more steps that we have to do to be able to get that working. Now, if we go take a look back at the GitHub link, at the very bottom there's this option that shows using the Underground Nexus, and it shows 1, 2, and 3. If I select these, it will load up a guide with images, so it shows you how to find it, and then it shows that you want to choose this thing that says add connect. Now you can look at those screenshots, but I'm going to just show you what these screenshots show. And what that is let's say that I want to connect virtual machines on a system that's not really set up for virtual machines yet. Then you want to go to the menu, and we can go over to all, and we're going to scroll down and look for our virtual machine manager. Once we are at the virtual machine manager, chances are it's not going to work with anything yet. So you'll want to select add connection. And when we go to add connection, you'll have these options here. And it is very important to choose the right option, because if you just choose plain QEMU KVM, it's not going to work. You'll want to make sure very, 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 very specifically that you choose the user session, or it won't work. And if it doesn't work, I'll show you what to do next, because there are other things to do. So if we then say, we'll select that and say connect, you can say auto connect is fine, and if it finds your session, then it will just work. If it doesn't find your session, the way to troubleshoot that, so I'm just going to say this is what it should do unless you're experiencing bugs, what we just went through. If you're using a Raspberry Pi, it should be the same kind of general process. I already have it set up on, well, I guess I already have the application open. I already have it set up on the Pi, so it's already running things, but notice that it says user session right there, and that's the part that's important. Now, I'm about to get into where it gets real confusing. Once we have a virtual machine manager up and running, there are different ways to get images for things. So if you need images, then usually there's some operating system you want. If you wanted to say download Windows 10, Windows 11 you have to do some things to make it work, because you have to disable TPM, so you can run Windows 11 in this, but Windows 10 is a little easier to work with. You want what it says, like where it says ISO file, that's what you want. And you can come in here and look for an option to choose an ISO. And then if you grab an ISO, then you can go ahead and download your ISO. That's how you can get a Windows download. I think it's downloading, but anyways, normally it's just going to download it. But yeah, so just read the stuff and then follow the things and go get your ISO image. You want that ISO file. Shows that there's more options, all that good stuff. Now, let's say that you wanted Ubuntu, you could say, or Linux. It doesn't really matter, it doesn't have to be Ubuntu, but Ubuntu is just one of many Linux operating systems. You can just come over here to download on Ubuntu and just choose which version of Ubuntu you want. So Ubuntu server is pretty easy to test with. It has an option for manual install. These little options are weird down here, but anyways, if you select manual install, then you can just download Ubuntu, and then you end up with a bunch of downloads. So regardless of whether or not you save those downloads, if you don't save them, obviously you won't get the files. But once you have those files, then you're ready to start building a virtual machine. Now, I will say, if you're not building a virtual machine that uses the same hardware as the host you're using, it can be a little bit of a journey to get the virtual machine running. So we're going to kind of stick to what does it look like to configure a virtual machine that is running. So let me close these items, and I'm just going. I'll let folks kind of play around from there, and maybe later on I'll show like how to configure these. But just to give you an idea of what they look like once you have a virtual machine running, then you get these little items. If you close them, it doesn't actually close them. You can tell if it's running or not here, and you can either have it open or closed, and it doesn't close the virtual machine itself. It's just a little system that runs. And this is a virtual machine using the same hardware platform as the system running the Underground Nexus. For those who are a little more technical, that's AMD 64 is the architecture, not the same as a Raspberry Pi. A Raspberry Pi is what's known as ARM. You can come in here, have your little login, and have a whole nother computer inside your computer. You can do this with Windows too, of course. This shows right here that I do have a Windows system. I'm not going to boot the Windows system for now. I think I did in the last video. So I've already kind of shown Windows, but the point being, you can definitely start Windows systems just like you can start Linux systems. And if you are running these as servers, the neat thing is you can just, I'm pretty sure I can close this too without closing everything. I'm sure it's just going to run in the background. Let's find out. It's designed to be a data center, so you can just have a whole bunch of virtual machines do it and have it be like a VM farm and put it on a beefy host. So like the system that I'm doing the stream from has like 64 cores and 128 gigabytes of RAM. I run like a lot of these, more than probably the cores that I have because I have really beefy cores. But let's just go see. It should still be running. Yeah, so it's still running. And you know, it just, you don't have to worry about accidentally closing it. Now, if you're looking at this little I button right here, you'll notice that if you're trying to configure your virtual machine, it has these little toggles. The I is how you come in here and modify items, but you're not going to be able to modify anything while it's running. But this is where it gets a little interesting, is when you're modifying a server, you can choose the hardware that you want to use. If you use the options that say KVM, that uses a kernel-based virtualization environment that technically isn't based on specific hardware, so it's a generic platform. QEMU is fully emulated and isn't using kernel-based virtualization the same way. That's kind of confusing. But basically, if you want a pretty much fully emulated system, then you'd want to use QEMU 32. But you can emulate different chipsets as well, and that is where it then starts to get interesting, because if you decide that you want to spend enough time, I'm going to get into like some of the more advanced things. Now, Jermaine, before I get into like something advanced like running a virtual machine that would otherwise never run on the hardware, like having a Raspberry Pi run data center hardware level virtual machines, aka AMD 64 virtual machines instead of ARM virtual machines. Any questions before I get into the crazy stuff at a high level?
Not yet. Like, I'm still like, all right. I guess the just seeing the amount of sections that you can open up, and then thinking about scaling it to something like AWS or Azure, whatever you choose to do, you can really build out some insane VM farms if you wanted to. I think like this is crazy.
It is pretty crazy because I've already been doing it. I'm like, because I have a hypervisor and I've been using this more than my hypervisor lately because it's snappy. It's just I don't know. It's a weird little lightweight environment. Because it emulates things, it just kind of spits them out, and then I can have a whole bunch of them, and it's like easy. You can pause them. As a matter of fact, you can even save them, which this one doesn't have a snapshot, but I'm going to show one that has a snapshot. You can save these virtual machines in an exact precise state where they would have left off with something. I guess I could show that with the Windows one. It's not the end of the world if I pause this. So if I just pause this, you can just pause them. I love that. You can pause virtual machines with like VMware too, but like look at how fast that was. I didn't have to wait for the little like VMware like pausing now bar. I hate that thing. Anyways, then I can just close it, get out of here window, and it's not using my resources anymore. So I can come in here and say, let's turn on this Windows box that I don't remember what it was doing. And then we got to say open. We got our Windows server coming in here. Let's change the view to resize this VM, and then I'll show hardware emulation after showing, I guess, save state. Scale display. Let's scale the display. It's thinking. It's logging into Windows. So it does have a Windows, or the ability to run Windows. It's just a Windows computer now in there. You can full screen it, so if you wanted it to be full screen, you can do that. I'm not going to make it full screen. But the thing that's interesting is you can have these saved at exec state. So like, let's say that you had a game or something like that. This is, I think I was trying to show this last time, but I had things conflict. But I can just come in here and choose this thing and say play. Are you sure you want to do this? It's going to basically wipe out everything that is currently on the virtual machine and go right back to exactly how this thing was once upon a time. Oh, I have to modify some memory stuff. So maybe I won't do that at this exact time. Wait, max memory state. I guess I have to shut this thing down, modify the memory, and then it would work. So shut down. But either way, I'll show you on another system because now you know. Well, I can run games. If this right here it's playing Owlboy. I don't need to boot up a game right now, but you can stream games to other systems remotely from it. You can do some crazy stuff. So anyways, so you can build like cloud game streamers. If anyone wanted to learn how to do that sort of thing, you build Minecraft servers, things like that. Sometime we'll have to go back over your environment, Jermaine. Maybe in the next session we'll let you kind of start like kind of going over your little demo environment and sandbox, especially now that we got like all the audio looking good. I think it's been really clean stream this time. But yeah, next session we're doing another session on Thursday. But let me get to the Pi before I just rant forever, because that's what I do. If we go to the Raspberry Pi, let's say that you wanted to run AMD 64 applications, aka like applications that are not compatible with the Raspberry Pi. Well, for those who are technical, you'll follow this. If you're not technical, you're probably going to be like, I don't understand. The part to take away from this is how to make the Raspberry Pi compatible with applications it's just not compatible with. Like, for example, you can't run Zoom on a Raspberry Pi, but you can run Zoom on a Raspberry Pi with emulation. You can emulate Zoom, but you can't just like go and install it and run it. This is emulation that we're getting into. So if I were to type ARCH, your conventional laptop or desktop that you use generally, if you were to open any terminal and type this ARCH64 means that it's what's called an ARM chip, an ARM chip, versus if I come over and select the option in here, let's say that I then unpause this scary thing. Let's resume it. So this is an AMD 64 virtual machine running on a Raspberry Pi. It's just an operating system that's shell only. So this is not, it's Ubuntu, but it's not a desktop operating system. It's a server operating system. Unlike, so this Ubuntu, let me unpause it. This is Ubuntu Desktop, and Ubuntu Desktop has this beautiful, glorious desktop, and you can come in here and, well, it's waking up, but more importantly, let me come and type in a terminal here and mate on this shell, and if I type arch again, put it up here again, so ARCH. If I type this, then notice that it gives us this x86-64, and it does not say what this says, where it says Arch 64. That's really important. That tells us that it's a different hardware platform, and they're not going to be compatible with the same applications at all. So that's important. And then, of course, this little virtual machine back here that's waking up, it's going to say the same thing that this says. That's my takeaway. So I don't need to worry about that right now. I'm just going to leave that alone and focus on. Let's take a look at the interesting thing. So let me put this where we can all see the bottom of the terminal shell. Okay. Oh shoot. I moved it way too far. Where is it going? Okay. Now we can see the terminal shell. So if I type the same thing, notice this says x86-64. This is the part that's interesting. So this is generally not possible. If you were to say that a Raspberry Pi could do this, most people are going to say that's not possible. But with the Underground Nexus, it's possible. It's possible in other ways, but the point of the Underground Nexus is that it's tooled for it. I will say that to get the Raspberry Pi ready to do stuff, you might have to add the dependencies, which I have that sort of like preset up here. But the way that works is if someone wants to go and add QEMU dependencies in their Raspberry Pi shell, then they would just type synaptic. And to get into emulation, you can add dependencies for x86 this way. So you have to come into this crazy thing. And once again, I just typed synaptic in a shell in case someone, you might have to go back and pause it to see how I got to this window, because I did not click on anything to get to this window. I just typed synaptic and hit enter. And then I clicked OK through the prompt. The prompt is saying that this application's not allowed to just install things, but what it can do is it's allowed to generate install packages. The purpose of that goes back to DevSecOps. I don't want random people just installing random things and being like, I just broke the Nexus. Well, this way you have to inspect anything and then run it manually and know how to run a script to do it, so it's a safeguard. So if you don't know how to run a script, you shouldn't be playing with this anyways. But if you are getting into QEMU, then you can type QEMU in here, and this is going to have anything else too. So whatever you're trying to install, not just QEMU. If you can install it in Linux like Docker or anything else, if you're not sure how to install it, this manager has a way to add dependencies for things. So scrolling down in here, we will see one of these. There it is. Notice that it shows that one of these items is QEMU System x86, and it says QEMU Full System Emulation Binaries. This is exactly how we get x86 on a Raspberry Pi, and then you have to, generally the way that I would add this script or the package builder is you come over and select the items that you want to install. So I'm just going to select something that that's not that. And then it'll say mark for installation. You select mark for installation. And then say mark, but we're pretending like I selected the x86. I already have it selected, so I don't need to select it again. And then you simply say generate package download script, and it's going to let you add a name to your script, so you can say whatever you want to call it. Be like Kimu stuff or something. You put it on your desktop, you could put it wherever you want. I do recommend making a folder for it, so right here you'll notice that I created one called Kimu in the past, so you can just say like create folder, which is what I recommend doing. Just choose what that name is. I had made Kimu, so just make a folder. You'll notice that there's a script already in here, but I'm just going to say save, and once I save that, I can close out of this crazy application, and in the directory that I made, it's going to give me Kimu stuff, and that's going to install the other things. Now, but really, this one right here is the script that if you were to create the x86 script, this is it. I just named it differently, and then you would want to install it from this terminal, so you can basically kind of do what I was doing earlier. You can get the directory of the file location here, and you can copy this, and you can go to your terminal, and you can say cd, and then you should be able to see your scripts in there. And then the way to install stuff, I can just run this because it's not a big deal to just kind of show like what does it look like to run these. The first thing I'm going to do is clean these up. So you can get rid of all of those .deb files by typing sudo rm space, and then notice asterisk says all .deb files. So I just want to say asterisk.deb, and boom, notice I got rid of all the .deb files. Now I'm just going to pretend like I never ran that before, so I'm just going to say sh, well, I have to say sudo first, so make sure you say sudo. And it's thinking because it has this virtual machine running in the background, so maybe I pause the virtual machine real quick. Let me refresh the whole window. Plus, I should probably pause the VM before running the script. Anyways, if you are using a Raspberry Pi to emulate, emulation on a Raspberry Pi can cause other things to run slowly, just as you're seeing. So if you are running the Underground Nexus with something else. Well, anyways, for now, maybe I made the Raspberry Pi too angry. Oh, it seems to still be running. But yeah, I might have to give it a nudge. Yeah, if you have a virtual machine that's emulating a different platform running in the background, depending on how you configure it, I configured it to use all cores and eat up the maximum amount of RAM that it's supposed to be able to use. So that's going to make a lot of things angry. I would recommend not using more than half of... So let's say that you have a 4-core system. Use half the cores. Don't use 3. Don't use 4 cores when you're configuring a VM on a 4-core machine. Or this will happen. This is what happens when you do that. I would recommend configuring a half. So 4 cores, just put like 2 cores on it. 2 cores, and then don't use too much RAM. Use like 2 gigs of RAM or 4 gigs of RAM. But don't overdo it, especially on the cores. You'll notice on this system and its configuration, I very specifically am making sure that it's not really using that many cores. Notice it has the ability to handle 8, but I'm only giving it 2 cores. I'm actually giving the one on the Raspberry Pi, which is also a much weaker system, more cores than I'm giving this. which is a much beefier system that's hosting the Underground Nexus. So you will run into a few things like that, even if it's not quite crashing. So anyways, that kind of covers, how are these things set up. But yeah, that shell script, the only thing that you missed on that is like, how do you run that shell script? And just how I removed all of the shell scripts, you can run all of the shell scripts the same way. Like if I go back and look at this where it says star.deb, instead of rm, you would type sh space star.deb, and then it would just run, or not, sh in the script, and then you would say dpkg. Well, one of these days I'll put more guidance on how to use that script building tool. That might be a thing on its own, or like its own lesson. So since that's going beyond virtualization and all that stuff, that's just showing like how to get access to the binaries. I know there's a lot, and it's just pretty chunky session today. So what are your thoughts today, Jermaine? After all that?
No. Well, I'm happy you did that, because I actually, I guess I can share my screen.
Oh yeah,
I just ran that script.
Yeah, share away. So if you share your screen, let me know, and there we go. I'll make your tile bigger here so that everyone can see.
I don't know. Can you see it?
Yeah, I can see it good enough. It's a little fuzzy, but maybe I can make it a little bigger too. Let's see, focus, grid. It's a little bigger. That looks pretty decent. Yeah, it's good enough for folks to see generally what's going on.
Yeah, so I just did exactly what you were saying, and I followed along.
Oh, very good.
There goes the QEMU folder. I put it on the desktop.
And that's on a... Oh, cool.
This is on the Pi, yeah.
Okay. Yeah, and then the command that you want to use, and I guess I'll just type it on this screen here, but you want to type in that folder sudo dpkg space -i and then star.deb. So if you type that in the directory that has all the deb files, oh, I guess I should show my screen so that you can see the command, because I think I'm covering it. Let me shrink.
Actually, I do see it. I see your screen.
Oh, you can see my screen?
Yeah. So sudo dpkg.
Oh, okay.
That's a -i, right?
That's right. And then figure out how to temporarily show everyone. So for those watching, that's the command right there, sudo dpkg space -i space star.deb. That's the command. I'll leave it up for a bit, and then I'll show Jermaine's screen again.
Okay. And there it goes. Nice.
From YouTube, when you...
Oh, well, tell me the question.
If you cluster a Raspberry Pi and a standard system together, could you run without emulation?
You would have to tool it. That's it. So, so someone was wondering if they cluster a Raspberry Pi with a different system, they would have to just make sure that the build code builds on the appropriate system, which you can do. Which it just depends on how you cluster it and then how you structure the commands to go where, and you can tell things to say, when you run a system that's compatible with x86, then run to this system, and if you see something that's not x86 like ARM, then run to this system, and then you could, I didn't even think about that. You could take a Raspberry Pi, you could take a cluster of Raspberry Pi and x86 combined, and mesh them together and use Swarm as a sidecar proxy model. That's crazy. You can use Docker Swarm like sidecar proxies. I've never thought about that.
Cool. Well, shout out to the YouTube audience.
Shout out to the YouTube audience. This is why we do these, because how would we have learned that? I would have never thought about that, Jermaine. Would you?
I think eventually would have bumped into it.
Yeah, that's pretty sweet, actually, because you can cluster, just because I was showing that earlier. I have these nodes aren't online right now, but they're available as it showed in the Swarm.
Yeah, because I'm definitely gonna mess with the clustering this weekend. So I wanted to, at least what I want to do is I want to do the Proxmox hypervisor. I
Yeah.
want to set up uh, 4 different VMs in there, and then use the Pi as the main. So that would be the manager, and then those 4 are going to be the workers. So I want to see how that's going to go.
That'd be sweet. Yeah, so someone could totally string. Oh man, these
But
are amazing.
but without that question, then after that, like I would have ran into problems. I'm like, what the hell am I doing wrong?
So many good
So,
ideas. There's because like we just made this thing, and I don't know. I don't know anyone else who's made copy paste data centers before, but now that we have them, I mean, we're learning all the things from everyone's ideas all at the same time. I didn't want to distract what you were in the middle of either, Jermaine. So I guess where were you on your build too?
I don't know. So I just did the setup on my side, so I could.
Oh, very nice.
Cause I know that you weren't able to show it, so
It's showing your
I just
screen.
wanted to follow along too. Yeah, so there it goes. I set it up and
Oh, nice.
installed everything,
Oh, that's
all the packages.
amazing. So then you should be able to go to the virtual machine manager, and in the virtual machine manager, it's going to ask you what kind of platform that you're using or that you want to use on your virtual machine when you say new virtual machine. Look at the bottom, that little caret thing. Yeah, see that? Click that. And then notice it lets you change your platform now that you have multiple emulation platforms. For those who can't see what's going on, well, I guess it's kind of hard to see what's going on.
Yeah.
I guess I'll show it on my screen too so that folks can kind of see what that looks like. So I'll pull up
Yeah.
my Raspberry Pi. I was able to pause the virtual machine in the background, so it should, my machine should be alive again in a bit. I'll just close the virtual machine for now. So what Jermaine was doing that's kind of hard to see is when he went to, say, new virtual machine. There is this, still kind of hard to see, but it says architecture options here, and I'll leave it open. And the little drop down menu that appears, notice that it lets you choose from x86 now, i686 is an option on here, ARM that's not, Arch64, and ARM v6L. So you can emulate different platforms, including, I guess, of course, like it's an ARM system, so it can emulate ARM. That's a little more direct, but yeah. So that's the more advanced. If anyone's saying this looks yes, this is very complicated stuff. This is not simple. This is the kind of stuff that people get paid like 6 figures to do. So for anyone watching this, being like, well, this is really hard to follow, we're going to be doing a lot of these sessions because it is really hard stuff. We simplify it so much because in reality, what the Nexus does and configures when you start it up, and it takes a while, it took us years to build what it does. Like we had to manually build it. The total development process for me to get this thing to where it's at now is about 5 years. The amount of time from us taking what I had done before, which is an Olympiad project that I work on and I'll probably forever work on, but that took another year from having an entire platform built to then build an entire platform from that platform being this platform. Like, this stuff takes a long time. And so, like, while now you can do what took us years to build just by doing, like, a copy-paste, and you don't have to know any of the stuff that we knew to build it, you can just use it. So you can get the benefits of, like, okay, so I want to work with Git. Okay, I want to work with these tools. I want to work with this or that or whatever. We make it so that you could just get right to it. my goal is to skip a lot of the dancing so that you can just like, you know, just learn, like, just get right to using your repositories, you know, get right to running your Visual Studio Code, get right to setting up and running your pipelines, making sure that all of your Git is centrally accessible, making sure that it's secure and monitored so that, you know, you can come down here and immediately see if there is something that might be threatening your environment. So if you're in here in my environment, I can see you. You know, there's a lot going on. And there's a lot happening just like under the hood. And then the fact that you can just open a port and turn it into a NAS. You just open up a port, boom, now you have a NAS for your whole home or office. And then you can add a VPN tunnel to it, so then suddenly now anyone can globally access your Nexus. You just add a VPN to this, it's global. And then anyone can just connect to your Nexus with a VPN tunnel. That's probably the fastest way to share your Nexus with anyone, anywhere. And what I did learn is that this experiment here with these clusters, one of these clustered successfully over VPN, and notice that over the VPN it still shows active. Over VPN it's still showing that it's actively available for me to go connect to. Right now I have the port blocked right now, but you can cluster over VPN. And you can share and distribute your services no matter where anyone lives without a central server. And it'd just be like one big giant like everyone can have a part of the data center. Everyone everywhere can be a part of the data center. Anyways, that's crazy. So that being said, I guess that kind of covers most of our stuff for the day, Jermaine. Do you have any thoughts about anything else that you wanted to get into, or anything else that you want to cover before we kind of wrap this session up? The next session, I guess, we'll get into like the package builder, how to build and automate more packages, things like that. And oh yeah, that's right. The next session, don't let me forget that. We got to show how to create hidden domains at a high level preview. Hidden domains live.
All right. I mean, I feel like there's so many things that you don't touch on that's possible. And I guess like it's like you said, you're the creator, so you look at it differently, right? Like I look at it, and especially like come from my gaming background, I'm like, oh my goodness, if I was a game dev, and I love indie games, like, and you want to do like a really cool LAN indie game, but you're not sure how to really test it, like this is a perfect environment. And the cool thing is that you get to push your graphics card into it too, so you can actually use your graphics card and truly test all this out. Like
yeah, what Jermaine says is true. You can start to learn acceleration with this, because you can do graphics acceleration and 3D accelerate. Anyways, it gets dizzying.
Yeah, it's just insane. It's like I'm nerding out thinking about all the different ways somebody can use this. And it's like, you could be a student, you could be a game dev, you can be act like a dev that's in a corporate environment. It doesn't matter,
It's pretty sweet. Yeah, it is true. It's like you can be solo. You could, like, as a solo developer, you can have a stable, secure, continuous pipeline. As a small team, you can have a shared continuous pipeline. Small team. If you're a single person and you suddenly now are like 2 or 3 people, boom, you just set up a VPN. Oh, hey everyone, I just set up a VPN tunnel. Okay, great. Now everyone can work together immediately as if we had our own data center, be the data center. Like, and then everyone can have their, like, as you earn money, you can get better hardware and scale up, because it's easier. It's because it runs better on better hardware too, just like anything else. It's like video games. You have like your minimum specs, and you can play like World of Warcraft on minimum specs, or like, I don't know, a game like Resident Evil on minimum specs, and it looks fine, plays. You play the game, see the story. Or if you have like the right hardware and you got the beef and you got all the stuff, you did all the configurations, then you can get the premium experience. You can get that 4K. You can get like all the, rendered textures. you could, all this stuff that you don't need to still play the game. Like you can be a person playing on a laptop with terrible graphics on like Destiny, at playing with someone who's got the amazing graphics playing Destiny, and both of you accomplishing the same goal. It's just one person has shinier graphics. That's kind of how I see the Nexus in terms of scaling. It's like, yes, it's going to shine more on something that's more powerful, but do you need the beef to just accomplish the job, accomplish the goal? You're playing like a game like Monster Hunter. It's like you're playing Monster Hunter whether it's minimum specs or maximum specs. It doesn't matter what game you're playing. It's like, I guess so. I guess I come from PC gaming, so that comparison makes sense to me. How did gaming get you into building? I guess is the last story before we get into I guess wrapping up this session.
Well, I guess I've always been into. I grew up on PCs, like legit. This is all I really knew for a very long time. If you were supposed to talk to me about sports, anything outside of a computer, I would say no. I don't get it. Like I grew up in IRC rooms, just talking, and like AOL progs, and there's I still remember playing this FPS named Scarab on Windows 3.1.
Nice. I remember that game actually.
And dude, that was a great FPS. Like that, when I really think back to those days, I'm like, oh my goodness, and I think what really got me into the building part was, I think it was really the AOL days. I'll be honest with you. The AOL days were very interesting because it was truly the Wild Wild West.
Chat room hackers and stuff.
Yeah, exactly. Look, my first experience as a person that got me, he social engineered me to download Sub 7. All right, I had Sub 7 on my computer. I'm like, what the hell? How's this guy open up my notepad and typing to me? And he actually he told me everything. He explained the whole process. And from there, I was like, okay, I love computers. I really love this.
It is crazy, yeah. It's so crazy because it's similar for me because it's for me it was my Dreamcast. I wanted the internet on my Dreamcast, and it only had a dial-up modem, but it was during the days when DSL internet was coming out. But it had a browser on the Dreamcast, and I would sit there and I figured out through that browser because you have a little Dreamcast keyboard, so I have my little Dreamcast keyboard on in the little Dreamcast browser. And I figured out how to get dial-up minutes from from just other people's accounts. I'm like, oh sweet, and in my head I'm 12 or something. I don't know. I was a kid. I didn't know that people were paying for this. I just thought it was free internet minutes. That's where my head saw it. And I was like, sweet, I can use this to play Phantasy Star Online. So my career started with Phantasy Star Online. For that very reason, I'm going to actually host Phantasy Star Online Blue Burst. The Nexus can host Phantasy Star Online Blue Burst. If you're down, we're going to have to play this. Anyone else who's interested, if you're in the DevSecOps Dojo, DevSecOps Dojo members are welcome to join the madness. But the Nexus can host Phantasy Star. And I used to spend so much of my life figuring out how can I get more minutes on this game because I had to do it through dial-up minutes. And you'll learn some crafty skills that can turn into a career doing those things.
yeah. I'm not sure. Do you remember Net Zero?
I do remember Net Zero. Yes, I do.
Yeah. So I was playing Ultima Online, and I remember I did back then whenever you dial up, I didn't know about all this area code and all this stuff, right? So I didn't know if you dial out of your area code, they're gonna build you. So I remember dialing out of my area code. I'll go over to the town over because it's no busy lines. I get online and then I'm online for maybe 12 something hours, and we get a bill at the end of the month, and this bill is $2,000 because I keep dialing into this outline.
Oh goodness, of course.
So my mom is like, nope, no more internet for you. And I'm like, what happened? I didn't know this was a problem. So then, of course, like she's like, no, until this gets figured out, you're coming offline. So I immediately figure out alternative, and I get net zero. And then I'm like, I'm gonna remove the net zero banner. I'm not gonna have this big banner on my screen.
Absolutely. Oh man, it teaches you stuff though.
It really does. It really does. You learn a lot,
And
especially like those private server type games, like Ultima Online.
oh yeah,
You get into those communities, yeah.
because there you got to understand what an IP is. You got to understand like what peer-to-peer means. You got to understand how to manage all that stuff. It's not as simple as people might think, because a lot of the old games you had to, like, if anyone thinks that the Nexus is complicated to set up, some of these old games, just getting to where you can play it is so much more complicated than getting the Nexus working. Like, shoot, you come into the Nexus and you go over to, like, how do you run this thing? Oh, you download Docker Desktop and you come down here and you paste two things. You choose the one that matches your hardware, and then you run the one that says activate, and you just copy paste both of these into a terminal, in the same terminal on the same system you installed Docker Desktop. Okay, done. Now you got Underground Nexus running easier than some of these old school games.
Yeah.
It even
You are so
configures
right.
the IP address stuff so that you can just come in here, and if you did it on the same system, I even made it to where you even know what URL to go to. You don't even have to figure that out. Unless you want to get fancy. Start doing remote hosting.
Yeah, you aren't joking, because now, yeah, this is just a script that takes care of a lot of the work for you. Back then, you open up an INI file, configuring resolutions, taking care of private IP addresses.
Right. It's like so crazy. Now it's definitely a different time. Like, I wonder if this dashboard is accessible on this one. But yeah, so I guess we might as well wrap up this session. I'm so curious to see if .30 on this system is configured. Oh, I'm gonna have to check that out. I don't know why I didn't check this IP address from inside these things before. Oh, maybe I should try it on the Pi, because this one's a fresh setup. But anyways, well, actually, I'm just going to try one. I'm going to type 10.20.0.30, no, 30, colon 2000. Alright, well, I'll have to figure... Oh, you know what? I bet it's on port 3000. Oh, we're not. Wow. I'll have to figure that out another day. I have done plenty to this thing. Anyone can express. Oh yeah, it does work in here. It does work. I have the wrong ports. Oh no, I gotta fix that. Well, clearly I have something to fix in the Underground Nexus. This dashboard is the Security Operations Center, living inside the Nexus, which is yet another desktop living inside the Nexus desktop that you can broadcast where you want to, like TVs and things, and it automatically adaptively reshapes itself. So if I sit here and refresh this, it's going to reshape to the size of whatever screen I'm using. And so this is for setting up Security Operations Center dashboards, and it's least privilege, so that if someone hacks this dashboard, it blocks things. Like, I don't even think you can access a terminal in this one. It's designed to not let malicious dabble be a thing. Oh, it does allow you to access a terminal in here. So you might be able to do something in here, but it's least privilege. It's all locked down in there. But anyways, I guess that works, and we will do things again another day. Well, thanks for this super long stream. And then in the next session, I'm going to ask Jermaine to kind of show off a little more of his lab experiments and things that he's been working on now that we've kind of talked over, like, what can you do with the Nexus? How do you just kind of get started with it? What are some things to do? So